friends, I am MANAS SENAPATI. This is your Parasat channel, ARYABHATTA Academy. Previous video, I explained regarding the electric charge and drift velocity. Today in this video, I am going to explain one of the key concept of current electricity, that is electric potential. Many times we confuse regarding potential difference, voltage. I think that through this video your confusion will be crystal clear. What regarding the confusing, that matter will be closed today. So children, without making any delay, it is better to start the lesson. The question comes, what is potential? Generally, potential or electric potential, we understood it is the ability or capability. But the question comes here, whose ability, whose capacity? Is it ability of, it is my ability? It is your ability? No. It is ability or capability of the charge. What I am going to explain here. So, one thing is that technically I shall explain what is electric potential. There is no doubt. But at the same time, there should be a feel. What is that electric potential? So before going the technicality of the electric potential, it will be wise just to feel what is electric potential. See children, suppose this is a free fall body. The body comes towards the surface of the earth. That is due to the Earth's gravitational field. Already you have studied in the lower classes. The direction of motion of the object downwards towards surface of the earth, I can say that the direction of a free falling body is decided by a term that is called gravity or gravitational force. Similarly, suppose this is a water tank. This is the level of water in this water tank. You think this is the tank A, this is another tank B, this is the level of water in the tank B. Now, both the tank I shall connect with a suitable pipe. What will happen? Definitely, the water will flow from container A to container B. What is the region? The region is the level of water in the container A. The height of the water. Due to height of the water, you can say that here potential energy will be higher. What you have studied, potential energy is equal to mgh in the lower classes. Okay, whatever it may be, I can say that the direction of flow of water is decided by a term, that is the level of water. I am not saying about the volume of water. The container may be more area of cross section, volume may be same, it does not matter. Matter is the height or level of water. That means the direction of flow of water is decided by the term that is level. Similarly, suppose this is a charged body, one more charged body is here. Both the charged bodies are in contact. If the two bodies are in contact, the charge will flow from one body to another body. From which body to which body it will flow, we'll discuss in this video. Before that, one more example you see. Suppose this is object X, this is object Y. The temperature of the object is 30 degrees Celsius. Here it is 20 degrees Celsius. Now the two bodies are in contact. So due to the conduction of heat, you will find that heat will flow from body X to body Y. How did I say that heat will flow from X to Y? I have mentioned here the temperature. You know that heat flows from a body of higher temperature to a body of lower temperature. So here temperature of X is 30 degrees Celsius, whereas the temperature of Y is 20 degrees Celsius. So definitely heat will flow from X to Y. I can say that the direction of flow of heat is decided by a term. That term is nothing but the temperature. See here. The direction of flow of water decided by level of water. The direction of flow of heat decided by temperature. The motion of a free fall body is decided by the gravitational force or by the gravity. Similarly, if the two charged bodies are in direct contact or contact through a conductor, see here, this is a charged body, this is one more charged body, both bodies are in contact, then I can say that charge flow from one body to another body, that is decided by a factor of term, that is called the electric potential. So I can say that electric potential is the state of a matter which decides the direction of flow of charge or direction of flow of electrons, or you can say direction of flow of current. So electric potential is the state of a matter, is the state of a matter which decides the direction of flow of charge, you can say flow of electrons or flow of current. So to give you a feel of electric potential, these examples I gave you. So now it is the time we go to the technicality of this electric potential. See here. Suppose this is a positive charge I have taken. You think this is a big positive charge. Surrounding this charge, there is an electric field. You might have studied about the magnetic field, the region in space around a magnet. Similarly, around a particular charged body, there is a field. We say that is electric field. More about that you will study in the higher classes. Okay. So how much necessary for you? Definitely I shall not forget to say. So this is a positive charge particle. Surrounding the charge particle there is an electric field is there. Now here is one more positive charge is there. You think that this distance is very far away. We can consider it at infinity. This charge particle at infinity. Why did I say infinity? The thing is that this is a charge particle. Surrounding the charge particle there is an electric field. That means we can feel the influence of this charge particle surround it. Up to how much distance we can feel? What is the influence of charge particle here? If I move away, it will decrease, but it won't end. So we consider that the influence of this charge particle at infinity is 0. So this is a positive charge particle, but this charge particle is very small. This is a positive charge particle, but it is very small. How much small you can imagine? That means, see, if this charge particle comes to any place, if surrounding that other charge particles are there, they will not be influenced by this charge particle. That much small you think. So this is a very small positive charge particle. Now I want to bring this charge particle from infinity towards this positive charge particle. So what will happen? So definitely there will be a repulsion, because this is a positive charge particle, this is also positive charge particle. For example, I am bringing this positive charge particle to the point A. But one thing, I have to bring this positive charge particle to the point A very slow. That means it should not get any acceleration. That much slow I have to bring it. Okay. So I shall bring it with very slow speed. That means, see, you will feel that however the velocity is not changing. Definitely it will move from one place to another place. But we should bring it with a very slow speed. That means you will assume that it is not getting any acceleration. So if I bring it from here to here, from point of infinity to the point, definitely I shall do some work. Means you can see that some work is done here. Because this is a positive charge particle, definitely it will repel it. I have to bring this particle against this positively charged particle, against this repulsive force. You think that suppose at this place, if I leave it, what will happen? It will repel, again it will go back. So I have to do the work against the repulsive force exerted by this big charge particle. So definitely some work will be done. That work you think that is WA. I have mentioned work done at the point A to bring the charge particle, that charge particle from infinity to this point. Similarly, if I want to bring it somewhat more distance, for example, to the point B, so definitely I have to do some more work, no doubt at all. Here if I leave this one repel with more force, because it is very close to it. That means to bring the charge particle from infinity to the point A, I have to do the work. If I want to bring it to the point B, I have to also do the work. So I can say that definitely some work is associated with the movement of this small positive charge from infinity to the point A or to the point B. So, my intention to explain what is electric potential. The work done for bringing this small positive charge from the point of infinity to this point, suppose that is WA. Now that WA I shall divide by the charge Q. The charge what I am taking it from infinity to this point, that Q, if I divide, I shall get WA by Q. Similarly, here I can get WB by Q. What I am doing? I am dividing the work done for bringing that small positive charge from infinity to these points divided by the charge what I am bringing it, what I am moving from infinity. So that one will give the electric potential of that point. So I can write this is equal to V1 or this is equal to V2. That means at the point A potential is V1, at the point B potential is V2. Now tell me between V2 and V1 which one is greater? So definitely V2 will be greater than V1 because we have done more work to displace from infinity to the point B in comparison with the A, because up to B it has travelled more distance in comparison with the up to A. So I can say that here V2 is greater than V1. One more thing I would like to say. This charge what we use, generally we say it as test charge. Why do we say the test charge? Because this charge we use to know the strength of the electric field. Test purposes we use. That's why we say also it is a test charge. So I hope that you might have understood what is electric potential. I can say that it is the amount of work done per unit charge. Amount of work done per unit charge for moving a unit test charge from a point of infinity to a point is called electric potential of that point. Listen carefully. Electric potential at a point is defined as the amount of work done per unit charge. Amount of work done per unit charge in moving a unit positive charge, positive test charge. So I said that it is the amount of work done per unit charge in moving a unit positive test charge. Why did I say positive test charge? Can you say? From infinity to that point. You can mention like this. Because that charge we used for test purposes. That's why I said that it is the amount of work done per unit charge in moving a unit positive charge from infinity to that point. So, I use the word infinity. The thing is that we accepted that, we assumed that at infinity, the influence of the charge big charge, what I said, will be 0. That's why I use the term infinity. So this is about the electric potential. Then mathematically what we write? Mathematically we write, I said that work done per unit charge. Mathematically we write V equal to W by Q. W is the work done, Q is the charge, V is the electric potential. What is its SI unit? Its SI unit is, you know the unit of work is in joule. Unit of charge is in coulomb. So SI unit is joule per coulomb, or we say that is volt. So volt is the SI unit of electric potential. Suppose the work done is 1 joule. Charge is 1 coulomb. Then I can say that electric potential is 1 volt. So I can say that 1 volt is the electric potential when 1 joule of work is done for carrying 1 coulomb of charge. So I can say that 1 volt is the electric potential of a point if the amount of work done for moving 1 coulomb of charge. So 1 volt is the electric potential of a point with the amount of work done for moving 1 coulomb of charge from infinity to that point is 1 joule. Like this way I can define 1 volt. If I consider work is done 1 joule and the charge is carried, for doing that work is 1 coulomb. Like this way I can say about the electric potential. So children, I explained the electric potential, but this electric potential practically we don't use. Then what we use? Then why did I explain? It is necessary to understand what is electric potential before knowing electric potential difference. That means I want to say that in practically we use electric potential difference. So what is that potential difference? Potential difference, or we say it voltage. I think all of you might have acquainted with the term voltage. In our day-to-day life, we prefer to say voltage in comparison with the potential difference. So now I am going to explain what is that electric potential difference. Up to now you learned, you felt what is electric potential. Now we will see the potential difference. See here. So I said that this is a big positive charge surrounding that electric field is there. Okay. Here is a test charge is there. All the time test charge we consider as a positive charge. I brought it here very slowly. I did some work. Suppose this point is A means I said the work done is A. For the time being, you forget the charge at infinity. You think that charge is at the point A. I have to bring it to the point B. Here is the big charge. Its repulsive force is there in this field, no doubt at all. The charge is at the point A. You forget the infinity. You think charge is at the point A. I want to bring it to the point B. Definitely, I have to do some work. No doubt. Because there is a repulsive force. If I don't apply the force, it won't come. Even after coming here, if you leave that force immediately to repel, it will go back. Because it is very close. Here repulsive force will be more, no doubt at all. So, definitely I have to do some work. The work done is here WB. The work done here WA. Here the work done is WB. Okay, that means potential at this point is WB by charge. Here is WA by charge. Just I said that. If I subtract these two, or I can say that this is potential at the point B. This is potential at the point A. So B is greater than A because I did more work to bring that charge to the point B in comparison with A. So I can say that the work done here is more. Both cases charges are equal. Same charge I am moving it from one point to point A and to the point B. That means amount of charge, the denominator is same. So I said that work done at the point B upon Q minus work done at the point A upon Q. That means potential at the point B minus potential at the point A. We say that is difference in potential, or that is potential difference. Delta V is VB minus VA. So for a convent you can use this potential difference also, like this you can write VB minus VA. VB minus VA. So now I can say that the work done for bringing a single unit of positive charge or positive test charge from one point to another point is called the potential difference between the 2 points. So children, clear? How much work done for bringing a single unit positive charge from one point to another point is called potential difference between the 2 points. See that? potential difference means electric potential difference. The amount of work done for bringing a single unit of positive charge from one point to another is called potential difference between those 2 points. How much work done for bringing a single unit of positive charge from one point to another is called potential difference between the 2 points. Clear? Mathematically, potential difference is also V equal to W by Q. It is also expressed in the unit volt. What I said for electric potential, same unit I am saying for potential difference, and it is measured by an instrument. We say that is voltmeter. So, in the upcoming videos, we will discuss more about the applications of this potential or the potential difference. I said that now I taught you electric potential. Throughout the topic, I shall use the term potential difference, means electric potential difference. So children, don't forget to share this video to your friends. As a result, they can also get the benefit. You may think that the benefit will go to me, it may be, but at the same time, it should reach at number of children. So I hope you might have understood what I want to say. So now I am going to explain the work done by a battery. Work done by a battery, or you can say work done by a cell. It's better I should write cell. So children, listen carefully. Suppose this is a cell. This end is positive end, this end is negative end. That means the cell is maintaining a potential difference between its ends. Now I am going to say how a cell is prepared, how does it work. Listen carefully. You know that inside the cell we use some chemicals. What we say? Electrolyte. What we say? Electrolyte. In that electrolyte, in that chemicals, number of ions are there. Those ions move in different directions when we are preparing the cell. In fact, any cell, two electrode will be there. One positive electrode will be there, one negative electrode. How this is positive, this is negative? Actually, that cell contains two metallic rods. We say electrodes. I am not telling positive, negative. I am telling it contains two metallic rods. One positive rod, two metallic rods. We say that is the electrodes. Inside this cell, What is there? Some chemicals are there. That chemicals provides the positive ions as well as negative ions. These positive ions move to one end of the electrode. Negative ions, they move to another end of the cell. This process continues until both the sides charge sufficiently. That means all positive charge particles are gathering in one electrode, one metal rod. All negative charge particles they gather at another end. Due to what? Due to a chemical force. You can say this is the chemical force. Electrolyte contains chemicals. There is some force. That force helps the charge particle to move in two different directions. Suppose positive particles came to this side, negative charge particles came to that side. The process continues, but at the same time, the charge particles, when they are moving, they experience another force that is called the electric force. Listen carefully. Chemical force make them to move in different direction. At the time of moving, they experience another force. That is the electric force. Okay? So, one stage comes where the chemical force and electric force both become equal. In the beginning, chemical force dominate over the electric force. But one stage comes where the electric force and chemical force both will be equal. That is the equilibrium state. That is the stable condition. That means this particle attracted by chemical force, at the same time it is attracted by electric force in opposite direction. One stage comes where both the forces will be equal. Again there will be no further movement of ions in any direction. Do you understand what I want to say? Suppose this is the chemical force, this is the electric forces. Now in this condition, again there is no movement of ions. This is the case with your dry cell what you are purchasing from the shop, from the market. When you are bringing the dry cells, there is no movement of ions to any side because the chemical force present in the electrolyte is balanced or neutralized by the electric force. So when both are equal, the ions neither will go this side nor will go that side. Okay. Before that, already the cell, one side is sufficiently positively charged, one side is sufficiently negatively charged. So positive end, this is the negative end. So this is the higher potential, this is lower potential. Okay. So here the cell, when connected with a circuit, what will happen? Listen carefully. Suppose it is written 1.5 volt. What does it mean? The mean is that 1.5 joule of work is done over 1 coulomb of charge. If I written it is 10 volt, that means 10 joule of work done on 1 coulomb of positive charge. So you think that if it is 1.5 volt battery or 10 volt battery, what will happen? Same charge I am telling 1 coulomb. This work will be done 10 joule. Here work will be done 1.5 joule. So where you will get jada jhatka, you can think. Okay children, now listen carefully. How does it work? I want to say the work done by a cell. Now this cell will be connected. Suppose there is an electric bulb like this connected. This is the positive end, this is the negative end. Here This is a metallic conductor. It contains large number of free electrons. Electrons are negative charge. The charged particles will be attracted by the positive end. When they will be attracted by the positive end, what will happen? In this case, electrons will gather more. That time, the electric force will less than the chemical force. When the charge particle, negative charge particle comes and gather here, electric force will be less than the chemical force. Then what the chemical force will do? It will pull the electron from negative charge particles from the positive side to negative side by the chemical force, because here the chemical force became more than the electric force when the electrons gathered here. But this is already a negative end. Negative charge particles are more are there. So these charge particles present here, they will repel the electrons. They will send the electrons. Each electron will start to repel each other. That means electrons started flowing like this manner from negative terminal to positive terminal. Okay. So this is the direction of flow of electrons, not the direction of flow of current. Direction of flow of current always from positive to negative. This is one conventional direct current. Actually, current is due to flow of electrons from negative to positive terminals. But the fact is that the time we came to know the region of current after the discovery of electron, before that we accepted that current flows from higher potential to lower potential. In practically, current does not flow from higher to lower. But earlier, when we knew the current but we did not know the region of current, that time we accepted current direction from higher to lower. So we say that is the direction of a conventional current. Okay. So whenever we say direction of current, we use the direction of a conventional current. If the question comes regarding the direction of electronic current means the current what we understood after the discovery of electrons. Then I can say it is from lower to higher. Otherwise, the direction of current always from higher potential to lower potential. So, children, I hope that you might have understood how a battery does work. More about the chemical reaction, reduction reaction, what takes place inside that. I think it will be more clear in the higher classes. What I said, I think that's enough for the 10th class point of view. So this is about the electric potential difference and the work done by the cell or work done by the battery. So one thing, remember that a battery can maintain a constant potential difference. Battery can maintain a constant potential difference between the ends of the conductor until it gets completely discharged. The time will come, the chemical energy will complete, the work will complete, the work of flowing the electrons in the conductor also will stop. So this is about today's class. The rest about the electromotive force in the next video I shall explain, where again we will compare the electromotive force with this potential difference, and I hope that what I have not covered in the next video, definitely I shall cover it. So that's for today's video. Thank you. Jai Hind.